Okay, guys. So again, somebody let me know if one of those three people come in, but we're going to go ahead and get started. One thing I'm going to do with all these sessions, I'm going to record them and try to post them on Google Classroom. So if you, for some reason, you miss or you can't get to us, then at least that way it'll be on there. It should be dated, and it's the Google Meet that we're doing. Okay. So plan for today. And what we're going to try to get done is back with these multi-step equations. Now, you know the pre-shifts we've already looked at. We've already looked at distributive property, which you're going to see more of that today. We're also going to look at combining like terms, which you've seen. And then we're also going to review some more variables on both sides. And that's what we started yesterday. So some of the equations we look at will have all of those in there. I've got my document camera pulled up over here by my desk, and so I'm going to be just talking and working the problems with you. Basically, this will be like a big parent share, okay? So we'll have a problem that I'll put up. You'll have some time to work on it, and then you guys need to talk to each other and talk to me. We used to call this hybrid G when I did this in class, and so hopefully you guys will unmic and get to be part of what's going on. Ask questions, help people, because that's the best way for us to learn, okay? So the end of the class, which I'm going to try to go about 25, 30 minutes in the live portion, and then I'll stay on an extra 5 minutes after that to try to help anybody that's still not on green, okay? So I want you to get on green, hopefully before you leave here today. But the last 2 or 3 questions are going to be special questions, okay? They're going to be different than what you typically have seen. They're going to be some that you have to take notes on because, like I said, they're going to be new to you, okay? They're still going to look the same, but you're going to come out with a different answer, and all you got to do is just be familiar with them. Once you see it, then you'll start recognizing it, and then they'll be probably some of the easiest problems that you have, okay? Thanks, Lauren, for trying to get that call out, okay? But again, you tell those guys for whatever reason, hopefully this recording will be on our Google Classroom before 3 o'clock today, okay? So let me switch your screen and get to where you can see me live on the board over here, but go ahead and finish the bell ringer if you haven't finished it already, okay? Okay, can you see me live right here underneath the document camera? Hi, everybody.
Yeah, we can see that.
All right, good deal. Okay, so tell me, and you guys just unmic and don't talk over each other, but unmic and let's talk about this problem. What do you see that's going to be something we've got to take care of first?
The distributive property.
That's got to happen first. Anytime you have these multi-step equations, you've got to take care of the distributive property because this is locked in there, okay? If there was something else out here, you couldn't touch this -6 because it's the key to unlocking this, all right? And so we're going to go ahead and draw our line, and then this is your course of action with distributive property. It's a number against parentheses. And it just means to unlock this, you've got to multiply this 6 times every piece inside here. So that's going to give me -6x. Remember, minuses are negatives, so -6 times -2 gives me +12. What's happening over here with these guys? Somebody on mic and tell me, what do I do with these guys?
You just drop them down.
Yeah, there's nothing to do with them. They're just hanging out, right? I mean, they're like, hey, look at all this stuff going on over here. We're just going to hang out. Hey, you -16, how you doing? Okay, so that's the first pre-shift. It's out of the way, right? Look for another pre-shift now. Is there another pre-shift, something we've got to do before the 3 steps?
The variables.
Right. We've got variables on both sides, don't we? Now, we know they're going to be like terms, but if they're on opposite sides of the equation, then we've got to get them together and we've got to follow the rules to do that. So I told you guys yesterday, take the smallest to the largest, but if you end up messing that up, don't worry about it. It's just going to give you a negative coefficient to deal with. If you take the smallest to the largest, it'll eliminate that, but it's not a big deal if you don't. So minus 6x, we undo that by adding 6x, and we do that to both sides. These are additive inverses. Bring down my 12. That gives me 4x minus 16. Okay, so we had two pre-shifts, right? The distributive property, we got that taken care of. We had variables on both sides. We took the smallest to the largest. Now we're down to just see what's been done and do what's been done, do it to both sides. So add 16. That gives me 28. It's 4x because those guys are additive inverses. Divide through by 4. And it simplifies down really nice, doesn't it? Okay. Questions on that? Okay, let's try another one. Everybody take a shot at this one. Kind of tricky at the beginning right there. How many people think you need to add 3 plus 3? Think that's a direction we need to go? What do you think, JC? Do I add 3 plus 3 right there?
No.
Why not? Looks good, doesn't it?
Yeah, but you got to do distributive property. So you take the 3 and multiply by what's in the parentheses.
Yeah, you're right. It's kind of a juicy trick because you sit there and you say, ooh, 3 plus 3, I need to add that together and make 6. But you're right, JC, the 3 is tied in with that distributive property, the second 3. So that first 3 is just going to have to come down and hang out, right? That's a nice call. Did we ever get Lily or any of those guys to show up? Thomas? Jace, I mean. I think we were missing Lily, we were missing Jace. There was somebody else we were missing. Hayden, did you make it on? Is he with us?
Hayden's gone.
Hayden is on. Good.
I said
There was one
gone.
other person we were missing. Brendan, are you with us?
Yeah, I'm here.
Okay. Like I said, I can't see. I have to change the screen where you guys can't see if I do that. But there was somebody else. Lily didn't make it on. Jace didn't make it
it was
on.
Lily.
Huh?
It was Lily. She said it wasn't loading for her.
Really? Okay.
Yeah.
What about Jace?
I don't know.
He's probably still asleep. That sucker. I wish I had his number. I'd call him.
Do you want me to call him again?
That'd be great, man. Tell him to get on.
Yeah, I said Hayden's not here. Like I said,
Hayden?
John's gone.
Yeah, that'd be great. Yeah, I knew there were 3 when I first started that weren't on with us. Have you guys had a pretty good day so far?
Oh man, we don't know what we did for language arts because something happened during that.
Yeah. How's it been in your other classes? Have you guys been hooking up okay, linking in?
Yeah.
Yeah.
I know some of the classes have been having problems. The only problem I had last period, my projector kept going out like it was getting ready to blow up and it was raining the
Jay said his Chromebook was at his mom's.
Oh yeah?
Yeah.
Well, tell him if he's got another device, just get on and listen.
Okay. He just hung up on me because
He
he's
did.
mean. Yeah.
All right, let's check this out. I know you guys, some of you may not be finished yet. What's going to be my first step? Jace already told us. What is it? Oh, come on now. I'm going to get the wheel.
Distributive property.
Yeah, distributive property. So this 3, again, it just hangs out. It looks real juicy. You want to put it together, but that 3 right there is locked into that distributive property. So this is what it's going to do, okay? It's just like unlocking for the next level in a game. You got to have this 3 as the key. So that's going to be plus 9x plus 15. What about these guys over here? Anything happening with them yet? Yeah, they're just hanging out, right? Okay, there we go. All right, what do you see now? What's the next pre-shift?
You got to do the variables.
Okay, now that's one thing you could do. It's not wrong to get those variables together, but what I would suggest to you first, do you see some things on this side that can go together?
Yeah, you add the like terms.
Right, I would put these together first. Again, as long as you bring those down and do that eventually, it's not going to mess your problem up, but it sure cleans it up a little bit if you do this. Just one step and put those together. And again, these guys just hanging out. You can even mark those out. And in the grand scheme of things, again, you could do it the other way, but I would clean it up. Now, let's deal with, we've got this variable, and they're on opposite sides of the equation. So we got to get them together, don't we? They're like terms, they're just not on the same side. So let's take the smallest to the largest. So -4 is smaller. So I'm going to add 4x. If I do it to this side, I have to do it to that side. So that gives me 13x plus 18 equals, these are additive inverses, so I get -34. Now again, I've kind of pulled the teeth, right? It's not a vicious animal anymore. It's just a little simple baby equation. See what's been done, undo what's been done, do it to both sides. So subtract 18. Here's your additive inverses. 13x, and that gives you negative, what, 52? Then divide through by 13. And we get x equals -4, right? Okay, how'd you hold up through that one? Hopefully I got a lot of you that were good with that. Even if you didn't get it exactly, maybe you're thinking, oh yeah, I know now, Mr. Corbin, I'm good. So that's what we're wanting. It's not that you get them all every time perfect, but the more you see them, the more confident you get. You know what to do and when to do it. Okay, let's look at a different one. Now, what I want you to do on this, I really want you guys to spend some time together. Okay, so the second that you come up with something different, than the regular problems we've been doing, I want you to stop the class and ask. Say, hey, did you guys get this? Or what do we do? What do you think we do with this? Because there's definitely going to be something different with this one. Nobody's gotten to it yet? Come on now, surely somebody is there.
There's a negative 8x on both sides.
Okay. So go ahead and get those together and tell me what happens after that.
Wouldn't we not have any more variables? Because if you add the 8, it would bring it to 0, which cancels it out.
That's right. So you're left with, when you bring everything down, the variable disappears, doesn't it? And you're left with what? Negative 14 equals negative 8? Is that true? Is that something that could possibly be true? That's not a trick question. Can negative 14 equal negative 8?
No.
The answer is no. So let's get everybody to where some of you are, because I'm sure there's some people that are still stuck. And let's see what's going on. So again, nothing happening here. Just waiting on things to happen on this side. Here's your distributive property. Okay, so that's negative 8 minus 8x. Okay. Now, if you see, you've got variables on both sides. So we've got to get those together. So a negative 8x, we add that. Do it to one side, we got to do it to the other. Additive inverses, bring down my negative 14. Additive inverses, wait a minute, bring down my negative 8. Well, what just happened? I just lost all my variables, didn't I? How can I come up with a solution? Because we've been coming up with like x equals 5 or x equals negative 2. How can I come up with that if my variable's gone? Well, this is a special type of equation, okay? And you're going to have two different things that will tell you what the solution of this equation is. The first thing you need to think about is, okay, when the variables cancel themselves out, in other words, no variable left in the equation, I've got two things that are going to happen. I'm going to look for. Is this something that's true, or is this something that's not true? If this is something that's not true, like this, negative 14 will never equal negative 8. Okay? Then what that means is that there's no solution. In other words, there's nothing you can plug in up here for X that will satisfy that equation. And there's just equations out there that are that way. There's just equations that no matter what you do, there's no solution for them. Nothing you can plug in for X that's going to satisfy it or balance it or make it true. So again, variables cancel out. I get something that's never true. Maybe 5 equals 0. Maybe 2 equals -1. Maybe 9 equals 10. You know that that is not true. Variables are gone. I know there's no solution. Okay? Now, compare that with this one. Try this. And again, same thing. When you get to something that's different, speak up and say, hey, what's up with this? Nobody's gotten there yet?
The variables got canceled out again.
Okay.
When I got like to the end, I got 8 equals -8.
Okay, you got 8 equals -8 or 8 equals +8?
Negative.
That's what I
Okay,
got.
well, let's
It
do-
was 8. I get the
Okay.
same.
All right, so the other problem was we canceled out variables and we got something that was never true, right? Like -14 equals whatever it was, but we knew that it was never true. And so the solution to that equation was what? The one we just did.
There's no solution.
There was no solution, okay? So now we solve this equation. Okay, we've got a distributive property, so these guys are just hanging out. That's -8y. And then a negative times a negative gives me +8 right there. Okay, so I've got variables on both sides. I'm going to get those boys together. Cancel that here. It gives me 8 equals, well, these are additive versus 2. I've got 8 equals 8. So what do you think, or tell me this, what's different from this one, variables canceled out, and the other one where variables canceled out? What's the difference in the two? Because both of them had variables cancel. What do you see with what's left? Right here.
This one equals
They're
itself.
both 8.
Okay, 8 equals 8, so that's true, right? Okay, this is the other scenario. You can either have things that, when variables cancel, you can have things that are never true, or you can have things that are always true. This is always true. This is called an identity. Write this down. Okay, it's an identity. And the solution is all real numbers. Well, in other words, you can put anything in for y, and it satisfies the equation. Sometimes we'll say infinitely many solutions. The other one had no solution, right? There was nothing you could put in. This one has infinitely many solutions. In other words, you can put any number in for y, and it's going to satisfy the equation. So these are just two special types, okay? And you know they're special. And when you see this, your mind should automatically tell you what the solution is. When the variables cancel out, okay, that's the clue. Variables are gone, and you're thinking, okay, this is not a big deal. I know what I've got left. I've got to look and see if this is true or if this is not true. If it's true, then you've got a solution of all real numbers. It's an identity. Infinitely many solutions. If you get something like negative 14 equals 8, then you know that's no solution because that's never true. Okay? So the key is, or the hint, anytime you see the variables cancel out, this is a good thing for us because it means my problem's over with. I look at what's left and I say, okay, that's true. That means all real numbers. If I see it and it's not true, then I know it's no solution. Okay? Infinitely many solutions, that's what all real numbers is, versus no solutions for the one that's never true. Okay? All right, so that's about our 25, 30 minutes alive. So what I'm going to do is I'm going to hang out here for another 4 or 5 minutes. If anybody else needs to ask a question or you've got something going on you want to talk to me about from previous days, I'm going to hang out here for a little bit. Tomorrow, you will have another assignment come on. It may be an IXL. It may be a quiz. It could be just a regular ed puzzle, like a video like I've been giving you. But there'll definitely be one that you'll be accountable for tomorrow, okay? Hey, I love you guys, and I wish I could see you. You guys stay safe, all right?
Do we have any more classes after this?
Do what?
Do we have any more classes?
No encore class. So that's it for the day, man. But take the time to do any of the problems and stuff that other people have given you. Get that done.
Okay.
All right. See you guys.
See ya.